Okay, so on November 11th and 12th, which was a Wednesday and a Thursday, I talked about conditional probability. And this is probability where we're not concerned about the population, but about a subset of the population. That's why it's conditional. Okay, so I'm trying to go from memory. This is a homework problem that we had on Venn diagrams. All right, and so the universe here is a total of 75 people. So if I was to ask what's the probability that somebody plays tennis, so that's 15 and 27. So that's going to be what? So that's 42 out of 75. And what if I was to ask the probability that somebody plays tennis and hockey? That's 27 out of 75. Okay? Regular probability. What if I was to ask the probability that somebody plays tennis given that they play hockey? Okay, so now my population is no longer the 75. It's the hockey people. So whatever is after the word given is my new population. Now the way we write this is T given H. It's kind of like a division bar. It's kind of like a division bar. So now I'm going to look at my population, which is hockey, and how many people are playing hockey? Well, it's 26 and 27. So that is 3, that's 53. And of those 53 people that are playing hockey, how many play tennis? And that's 27. All right, there's my answer. What is the probability that we have hockey if somebody plays tennis? So the key words for conditional probability is given and if. And whatever is after the word given, whatever is after the word if, that's my new population. So this is the probability that somebody plays hockey if they played tennis. Okay, so how many total people played tennis? All right, so what did we get from there? We get 2, we get 42. And of those 42 people, how many people play hockey? 27. Okay, we're not looking at the population, we're looking at a subset. Okay, so here's a table where somebody surveyed a bunch of boys and girls, and they asked them, what is your primary goal while you're in high school? And so the choices were grades, GR, sports, SP, or being popular. Okay, so notice that there were 478 people that were surveyed. 478 people that were surveyed. Okay, now, what if I asked you, what is the probability that I was to pick a person at random and I picked a boy? So do you see that's 227 divided by 478. What if I asked you, what is the probability that I was to pick a person and their goal was to be good at sports? Do you see that's 141 divided by 478. Okay, what is the probability that I was to pick a person at random and they were a boy and they thought sports was important? Well, do you see that is 50 divided by 478, because 50 is the intersection of boy and sport. Okay, what if I was to pick a person at random and they wanted to be popular and a girl? Okay, what's the intersection of girls and popular? As 30 divided by 478. Okay, now let's do conditional probability. What is the probability that I was to pick a person at random and they were a boy given they thought grades were important? All right, so now my population is great. See how it's after the slash is grades. How many total people here have grades? So let me change my pen. So I'm going to go to pink. Do you see here? This is grades. So my denominator is going to be 247 because that's how many people like grades. And of those grades, how many people were boys? 117. Okay, let's do another one. What is the probability that somebody that I was to pick a person who likes sports, given that they are a female? Okay, so I'm going to pick a color. Now look at, here are my girls. All right, how many girls do I have? Now my subset is girls, so that's 251. And of those girls, how many thought grades were important? 130. All right? That's how you do it, conditional probability, when we have Venn or table probability. All right? If you have any questions, please come in for tutoring.